Okay, good day everyone. Bismillahirrahmanirrahim. Okay, so I have two problems which I'm going to solve today. The first problem is for safety reasons, the entrance door to a storeroom in a supermarket must open and close slowly. Here, slowly is very important. A double acting cylinder is used to slide the door. So I have this picture. This is a door and this is the cylinder. When cylinder extends, the door will open or it closes, which one I prefer. And if the cylinder retracts, the door closes. So this is the mechanism. And the next problem is part of a manufacturing process involves dipping components into a chemical solution to prepare them before they are painted. So I have a double acting cylinder here. So when the cylinder extends, this portion dips into the fluid and do something. When this retracts, this full portion will move up from the liquid. So this is the case. And one important thing is these two problem is same, but it have to be very slow process, not fast extend and retracts. No, nothing like that. It have to be a slow process, and we have to be very careful because if this is not slow and this door is made of glass, then it will shatter instantly, and we don't want that. So let's go to the FluidSIM software. I'm using FluidSIM 6 if anyone is wondering. So first, I need a double acting cylinder. Here it is. And like before, I to control this I need a 5x2 DCV. Hmm, where is that 5x2 DCV? And to control this 5x2 DCV, I need two 3x2 DCV. One, and I will copy this after configuring. Configure valve. This is push button, spring return, and okay. Let's copy this, paste. Perfect. And I need supply and exhaust. Supply and exhaust. Here also supply and exhaust. Okay, perfect. This both side will be controlled with pilot, not this pilot, pneumatically operated. Connect this, and copy this and this, paste. Okay, perfect. Now, if I connect this line with this and simulate it, what will happen? Push. See how fast this is going? Very fast. We don't want that. What we want to do is make the process slow. So let's make some space and remove these lines. We need a flow control valve between this. So let's search the flow control valve. Mm, yes, I need this throttle valve. Let's make this here and another throttle valve here. Okay, so what will happen? When I push this button, then uh, follow my cursor. Liquid will go from here, then this side will actuate. Liquid will go from here to here, and this intersection, where will this go? Left or up? In the left side, we can see this is a check valve and it is closed. It is one way. so liquid can't go through here. So it will go in this side, and this is a restricted side to restrict the flow of the liquid. So fluid will go from here and here, and when it reaches this intersection, where will this go? This side or down? Of course, this side, because we can see this is open. Fluid will move easily here to this to tank. Now, let's simulate this. Okay, start. Then, before that, I have to make sure the opening level. Let's make the opening level 20, perhaps. Okay, 20. This side also 20. Great. Now, let's push this button. What what happened? It's still fast, right? It's still fast. So let's make the opening level more restricted, like 5, and here also 5. Okay. Now see what will happen. Fluid can't go through because the restriction is much more. Let's make this 10. 10. Also, this is much more restricted. What about 15? Let's see. Oh, didn't do well. Oh, I'm sorry because this side I didn't have to actuate. I have had to actuate this side. So 5 I think is good. Yeah, 5 is good. So see, much slower. It is very much slower than before. So what about 1? Let's see. It's it's very slow, very slow. I don't want that slow, but you got the general idea that how the circuit works. And one thing I like to mention is that this particular circuit has a name. So watch here. When I am pressing this button, it is moving slowly, okay, but what kind of restriction is there? The restriction is that when fluid is entering the cylinder, then I am restricting it, not when the fluid is going outside of the cylinder. So I am restricting the upstream. So this kind of circuit is called meter in circuit. I am restricting the inflow of the liquid. But if I make another circuit where I will control the outflow from the cylinder, that circuit will called as meter out circuit. So let's do that. Here, let's delete this too. Also, I can do it with this flow control valve, but I have a better thing here. Here you can see the check valve is reverted from the previous. This will work perfectly for our purpose. Let's add this. Okay, let's simulate this again. First, let's make this 5. 5 is good. Okay. So when I am pushing this button, this inflow, I am not restricting the inflow, but I am restricting the outflow. Here also, when I'm pushing this button, I'm restricting the outflow. You see that? So this means that this circuit is called meter out circuit because I am restricting the outflow, not the inflow. So these two term is very important. You need to know. So basically, with this, I have solved the issue, this close slowly issue, and that's all. Thank you very much.